All right, so we've got one more operation that we're going to introduce. So if we think about it, the curl of a vector field output another vector. Let's look at an operation that's going to output instead a scalar function. And it kind of makes sense. We looked at the curl, used sort of this concept with the cross product. Now we're going to look at a concept with the dot product. So the divergence of f of, which is mi plus nj plus pk, is really that del dotted with the vector value function f. So it's going to mean the partial derivative of m with respect to x. So remember, normally a dot product would be multiplication. Instead, we're sort of using this structure of it and using operations. So we're operating those partial derivatives with the appropriate components of f and adding them together. So the partial of m with respect to x plus the partial of n with respect to y plus the partial of p with respect to z. So let's find an example. Let's look at the divergence of this function, which is x squared y cubed zi plus 4xyzj plus cosine x times yk. So the divergence of f, we're going to get the partial with respect to x of the first component, which is x squared y cubed z, plus the partial with respect to y of the second component, which is 4xyz, plus the partial with respect to z of the third component, which is cosine of x all times y. So the first one, partial with respect to x, is going to be 2x, and then we'll keep the y cubed z. And then the second one, we're doing the partial with respect to y, so we'll keep the 4x z, and the y will drop out. And then the partial with respect to z, well, there's just cosine x times y in there, so the partial with respect to z is just going to be 0. So this would be our final divergence function. So it is a function, but notice it's a scalar function. It's no longer a vector value function. So a fun thing then that we can see is the fact is that if you take the divergence of the vector valued function that you get from the curl of f, it's always going to be, excuse me, it shouldn't be the 0 vector because it's not a vector, it's a scalar. It should just be 0. So the question is, well, why is that true? And this should be true for all vector fields. Well, if we think about what we've got, what the divergence is going to do is it's going to take a partial with respect to x of the first component, that I component. Now, if you remember what that first component was, it was the partial of p with respect to y minus the partial of n with respect to z. This is then going to do plus the partial with respect to y of the j component, which was negative the partial of p with respect to x minus the partial of m with respect to z. And then we're going to get plus the divergence is then going to take the partial of z of the third component, the k component, which is the partial of n with respect to x minus the partial of m with respect to y. So then if we just look at all of these partials, we're just going to get a bunch of mixed partials. So then we have the mixed partial, so we have the second partial of p, and then we have, with respect to x, then y, minus the second partial of n, with respect to x, then z, and then we're going to have minus the second partial of p with respect to y, then x, and then we'll have a negative negative, so plus the second partial of m with respect to y, then z. And then we've got plus the second partial of n, we'll have dz dx. And then minus the second partial of m dz dy. And then if we look at everything we've got, mixed partials should be equal. So the second partial with respect to p dx dy is the same as dy dx. Notice one's a plus, one's a minus. The second partial dx dz is the same as dz dx. One's a minus, one's a plus. And the second partial dy dz is the same as the second partial dz dy. One's a minus, one's a plus. So they just all cancel out. And you're left with 0. Which is pretty cool. So very similar to, kind of similar to the curl definition where we just have this del as sort of a placeholder for those partial derivatives. And then we're dotting it with the function, the f function there.